Hello everyone. So this time for another series, another video lecture on ray diagrams. So today I will teach you the principles of ray diagram first, and then we will again brush up our concept on ray diagram on concave mirror and ray diagram of convex mirror. So first of all, in order to draw this, as this is geometrical optics, your basic foundations should be correct to draw the ray diagrams, because there are many problems where combinations of mirrors and mirror and lens, at that time this concept which I'm going to teach you today will be very helpful. So let's start. The principles of ray diagram has four important primary laws which you can always obey to draw this. The first law states that any ray parallel to the principal axis after reflection will pass through the focus. What does this mean? Let's see. So if this is a concave mirror, this is the principal axis, and this is the ray which is parallel to the principal axis. After reflection, this ray will pass through the focus. So any ray which will be parallel to the principal axis will pass through the focus. What about in case of convex mirror? In case of convex mirror, let me draw one more. How will the ray diagram in this case? If this is the convex mirror, remember convex mirror is a diverging mirror. This is a diverging mirror. As it is a diverging mirror, so any ray which is see will pass through the. So in case of convex mirror, it will pass through the focus. So convex mirror cannot pass through the focus. This is the point focus, right? So any ray which will be directed, which is coming parallel, you see it is coming parallel. So after reflection, it will follow this path. This is a convex ray. Let us see. So this is the first law. Any ray parallel to principal axis after reflection will pass through focus. So you can see in case of convex mirror also, the ray is the paraxial ray, which is after diffraction is getting diverged. However, the ray seems to appear coming from the focus. The opposite, the ray in now for the second law, which is the opposite of the first law. Any ray originating from focus will become parallel after reflection. So let's see what does this mean. So if this is the principal axis, this is the concave mirror, this is any ray which is originating from focus. After reflection, it will become parallel to the principal axis. As simple as that. That's it. And this is our focus F. What about in case of convex mirror? In case of convex mirror, this is convex mirror. So this ray is directed towards the focus. Look at the arrow now. So after reflection, it will become parallel to the principal focus. This is ray diagram for the second law. Now let's come to the third law. The third law says any ray passing through focus will retrace its path. Not so focus. Any is not focus. Sorry. It will not be focus. It will be center of curvature. Let me cut it. Any ray passing through C or center of curvature will retrace its path backward. So let's see. This is the concave mirror. This point being the C. Any ray which will pass through C will retrace its path backward. And this is how it is coming. This is the point. This is the mirror. It will retrace its path backward. Fine. What would be in case of convex? How will it be in case of convex mirror? Let's say this is the convex mirror. Same thing. We'll take the ray here. This is C. It will retrace backward. This is the third law. Now, what about the last one? That is the oblique reflection. The oblique reflection states that if you consider any ray which is not paraxial, neither marginal. Now, what are marginal rays? The rays which are very close to the margin of the mirror and parallel are called marginal rays. So, if you consider any rays which is not parallel, so generally they will be incident on the mirror at certain angle, like this. So, in that case, you need to draw the normal now. The normal will be nothing but it will pass through the center of curvature. This is C. Then this will be theta. This will also be theta, obeying laws of reflection. Understand? It can be anywhere, not necessarily it has to be where I am showing. It can be anywhere, but it has to be not parallel rays. They should not be parallel to the principal axis. They should be at any other angle. Okay. So then this happens. In case of convex mirror also, same thing. If I consider this mirror, theta, theta. Clear? So these are called oblique reflections. Now we will learn the ray diagrams for concave and convex. And when I'm going to draw this, I'm going to use all these four principles to draw the ray diagram. And during learning of doing these geometrical optics on doing these ray diagrams for concave and convex, I'll also revisit these sign conventions. We'll try to apply the sign conventions in this case also. Okay. Okay, let's learn now the ray diagrams for the concave mirrors. Now I told you concave mirrors is extremely important. So let's start with the concave mirror first. First diagram. This is again a concave mirror. This is, remember, this is just a revision I am doing. This thing all you have learned in class 10. Everyone has learned this in class 10, but this is just a revision. This revision is very necessary to have a solid foundation on the ray optics chapter. So I am doing this. So now imagine the object is at infinity. So if the object is at infinity, the rays will be coming from infinity. So is this a paraxial ray? Any ray which is coming from infinity after reflection, it should pass through where? It should pass through focus. Correct? We have learned this. I will take one more ray. So the object, where is the object? Object is at infinity. Where is the image? Where is the image? Image is at F. What do you think will be the nature of this image? The nature would be, is it converging to a point. Here you see, there is definition what I taught you in the beginning. It's converging, so it is a real and inverted image. What will be the size? Size will be very small, point or highly diminished point size. That's it. Now just come to the next diagram. This was the first diagram. Just come to the next diagram, second diagram. Look at the second diagram. This is the concave mirror. The object is placed. This is C. This is F. The object is placed behind C. Now ray, we consider two rays to form the image. Two rays to form the image. After reflection, it will pass through the focus. Now here, either you can choose the C1, which will come here and retrace its path backward, or you can choose one more ray. I will just draw it like this. You see, it is meeting here. So this is the AB. So if this is my object A, B, this is the inverted image A prime, B prime. So where is the object? So where is the object? Object is behind C. Where is the image? Between. I write between, short form. Try to understand. B/W, between C and F. What is the nature? Is it real and inverted? Size diminished. Diminished. Okay, fine. Let's come to the next one. Third one. This is quite easy one. This is the object. So any ray, parallel ray, after reflection should pass through focus, right? And again goes to the focus, rendered parallel. So it will be somewhere here only, although they are intersecting here, but it will be somewhere here. Just a minute, I will clear it. So it will be from here to here. So from here to here. This is it. This is A, B. This is A prime, B prime. So the object will be, where is the object? Object at C, image at C, nature real and inverted, size same size. Yes. Let us come to the next one. Fourth. Now we place the object between C and F. Again I consider two rays. After reflection, it will pass through focus. This point is F, and then please try to understand I am drawing with my pen here, so that's why maybe little here and there it happens. Uh, so I will draw one more ray. So here is my object A, B, A prime, B prime. Okay, so object, where is the object? Object between C and F. Image behind C. Nature real and inverted. Size, what is this? Is magnified? Yeah, is magnified, enlarged. Let us come to the fifth one. This is very important. The fifth one is fifth and sixth of this concave mirror is very important, and you should always pay attention to this one. So keep the object at focus. So if it is at focus, yes, after reflection it should go, it should pass through focus only. Fine. And we will use that oblique projection. This is the one. This is the one. As a result, what happened now? This two is going to meet at infinity. So in this case, so here is the focus. Object at F, image at infinity, real and inverted, highly enlarged. So this is very important one. Let's circle it. It's very important. Let's come to the sixth, the last one. So now this is the focus. Place the object here. So you can see when I place the object between F and pole of the mirror, we find an erect and virtual image behind the mirror. So again, this is very important one. So the object is where between F and P image behind P or behind the mirror, and nature virtual and erect, size enlarge or magnified. Fine. So these are the 6 ray diagrams for the concave mirror. Now you see this table here. We're going to use it to learn the sign conventions now. To learn the sign convention, let's come to the diagram 1. So let me put the diagram 1 here. What do you think in this case object distance would be? Object distance is this side, on the left hand side. So u should be plus or minus. As it is, you are measuring from here. You're going to measure from from here you're going to measure from here in the direction opposite to u, opposite the direction of light. So definitely u should be negative. V should be, again you're measuring it from here to here, which is V. So V should be again negative. Focal length, again opposite to the direction of light, it should be again negative. What about R? R will also be negative. H1, what do you think would be the H1? It is definitely, it will be erect object. As it is erect, I am considering it to be as, although it will be very very far at infinity, so I am considering it to be as plus only. Here it is a real and inverted image, real and inverted, so this must be negative. Number 2, second diagram. In the second diagram, U is again negative, V, which is again against the direction of light. This is the DOL. This is the direction of light, and you are measuring the length this side. So definitely it has to be negative. So this must be also negative. What about focal length? It will also be negative. Radius of curvature, negative. What about H1? H1 is positive as it is erect. What about H2? Negative. Now let's come to the third diagram. For the third one, again same thing. U negative, V negative, F negative, R negative, H1 positive, H2 is also negative. Fourth one. In case of fourth one, same thing. Here also U will be negative, V will be negative, focal length is negative, radius of curvature is negative, H1 is positive, which is the object height, H2 is the image height, which is again negative. Fifth one. In the case of fifth one, let us see now. Here U is negative, V, which is again in at infinity, negative. What kind of image is this? Real and inverted. So if it is also H1 would be positive and H2 would be negative. Let's come to the last one. Here you look at the difference. Here focal length, here U is negative, V you are now measuring along the direction of DOL. This is direction of light. So in this case V will be positive, focal length negative, radius of curvature negative. What about H1? H1 will be positive, H2 will be positive. Okay, now we will see now we'll learn the ray diagram for convex mirror. So for convex mirror is very simple. There are only 2 positions. So this is the convex mirror. The object is at infinity. Let's say this is the object which is at infinity, The ray coming from infinity, any ray parallel to the principal axis, what do you know? It will pass through focus. So this is F. Okay. Now learn the ray diagram for convex mirror. Convex mirror has only two ray diagrams. So let me draw the convex mirror. This is the principal axis. The object is at infinity. Any ray parallel to the principal axis after reflection will pass through infinity, pass through focus. This is the ray diagram for first case when the object is at infinity. So object at infinity, image at F or focus, nature virtual and erect, size point size or highly diminished. Let us look into this second diagram now. Second diagram, you can place the object anywhere on the principal axis and the pole of the mirror. Any ray parallel to the principal axis, pass through focus, oblique reflection. This one will be theta, this one will also be theta. Now extend it, they meet here. So this is the object AB, this is the virtual image A prime B prime. So object, where is the object? Object is anywhere on the principal axis. Image behind, no, not behind, it will be between P and F. Nature virtual and erect, and size, it is diminished because it is not, size is not greater than the size of the object, so it is diminished. Okay, so these are the only two ray diagrams for convex mirrors. Now pay attention to the last diagram. You have seen in car vehicles that there are rear view mirrors. The rear view mirrors help the driver to see what the object or the vehicle or the scenery is behind the vehicle. So it is written on the rear view mirror that the object seems to be nearer than they actually look at it. What does this mean? This means when a driver is looking at the rear view mirror, all the images of his behind, on the behind, it seems very nearer. Look at the ray diagram and try to correlate it. this is the object, definitely u, this is the u distance and this is the v distance, definitely u will be greater, right? So the actual position you are not observing, you are only seeing the v which is closer or shorter than the u. This technology, this physics, they use, the car manufacturers use to provide relevant informations and guidance for you during parking, back parking, and um, yeah, that is. Now let's see the sign conventions. So let's do the sign conventions. So for sign conventions, first one, in this case u will be negative, as this is the dual, this is the direction of light, you are measuring opposite, so negative. V will be positive. Focal length, you are measuring the focal length from here to here, so this is the direction of your measurement, so f will be positive. And yes, convex mirrors focal length is positive, radius of curvature positive, h1 positive, h2 negative. Second one, u, this is the u which is opposite to the direction of light, so u will be negative. V is this one, you are measuring with the direction of light, so it should be positive. F should be positive, radius of curvature should be positive, h1 positive, h2 positive. Oh, sorry, in case of first diagram, the image formed is virtual and erect. That means although it is point size, we are thinking that it is erect image. That's why here also h2 will be positive. Okay, that's it. These are is the complete foundation on the ray diagrams of um, concave and convex mirrors. That is a spherical mirrors. Okay, see you in next video. Thank you.